That's what we're after. That's perfect. That's exactly what I meant. It doesn't like round. Have I done this wrong? Well, this is stuck in an endless loop. It's very pretty, but I've got no way of quitting it. Subscribe for more elementary C programming mistakes. We've had everything from not including the right libraries, to missing semicolons, to not initializing variables. Come join me, see what other basic mistakes I can make. Hello world! Actually, the world's a bit naff at the moment, innit? So come hide in here with me for a bit. We're going to do some nice old school DOS programming using C. Nothing surprising, nothing frightening, it's just going to be quite chill. If you're new, welcome. If you're not new, welcome back. This time I'm going to have a go at drawing some graphics. Programming books and early 8-bit machines never really explained graphics, they just stuck firmly with ASCII text. Well, we've got access to a massive 320 by 200 pixel display that can show a whopping 256 colours. I've got a vague idea of how this works, but no real plan, and I'll mostly be making this up as I go along, doing some good old-fashioned hacking whilst we're just coding stuff to see what happens. The first step is to work out how to actually draw on the screen in DOS. So let's go find out how to do that. We're going to make use of this website, which apparently is quite a classic one. It no longer exists on the internet as far as I can tell, but it's in the Wayback Machine. Before we dig into actually how to do any programming, it's really fun if you click around these old sites. He's got like a little blog. The amusing thing is this document is like a reference that everybody uses, but he actually just wrote it for a college class and put it on the internet. And if you scroll through this is how we used to blog, by the way, back in the 90s. It used to look like this kind of stuff. He used Word and converted it to HTML. Now, if you think web design at the moment is horrible, we had to deal with this stuff back when CSS was this new idea and they hadn't yet figured it out. So both Internet Explorer and Netscape did it differently. If you don't know who Netscape is, it's the people that eventually turned into Mozilla, then Firefox, and sort of similar, but a little bit different. Anyway, let's go back to the thing that we're actually trying to do. Oh, come on. What do you mean we're having trouble finding that site? I was literally just on the thing. What? Oh, for God's sake. We'll be back in a minute. We're back. No idea what was going on then, but never mind. So this website is really cool because it actually tells you things, like it tells you how a VGA screen is organised. It's just a big grid. And then it gives you code to make it work. And they've done it using Boolean C, which conveniently is what we're going to use. So let's get 86box running and set that up first. If you saw my last DOS videos, you'll have spotted me using DJGPP and RHIDE as my compiler and editor, claiming it was period correct and valid to use. Well, it is, but we're going to switch to Boolean C++ 3.1 instead. I even went as far as getting the user manual printed and bound so I could refer to it. You see, DJGPP runs all its code in 32-bit mode. Also trying to say it is a bit of a mouthful, which is fine if you're writing serious software. I'm not, I'm just farting about, scribbling on the screen as if I was a 2-year-old who'd found a marker pen and discovered their parents' living room wall. I don't need anything fancy, just a big blank area of video RAM and no crazy hoop jumping to get to it. No, I'm going to do some real programming. In real mode, I'm going to be a real programmer. Writing C, where you need to put all your variables at the top of the function where K and R intended them to go. The compiler claims to mostly be ANSI-C compliant. We'll see how far that gets us. I've even deliberately not cut my beard and let the greyness take over to look the part. I might appear like I've not slept properly, and you might think it's a side effect of doing this in my spare time at the end of the busy week. And you'd be right. But also it sets the scene, doesn't it? We're hacking C code on an evening. We're not sat with our MacBooks writing JavaScript in a coffee shop in the morning where it's nice and sunny. For a DOS program, this software is quite easy to install. It does come on a million floppy disks though, so if you want to do this yourself, go hunt around a bit for an ISO image that's got all the disk images on it together that you can just feed into your emulator. It's one thing having realism and like being, oh look at me, I've got a nice little DOS window that acts like a real PC. This is nice, it saves me the hardware. But swapping disks is a little bit too much. But here's how it installs. It's not very difficult. Tools installed, it's time to draw some pixels. So here we are, nice blank file. First thing we need to do is import all the various things that we need. So we need a bit of that and a bit of that. Possibly also that. One of these. So we need to go into mode 13. And we do that using that stuff that you can see on the screen. Be nice if I could spell. At least I didn't write onion like I have done before. So what this code does is it just sets the AH register to 0, the AL register to 13, which is what tells DOS how to change screen resolution, not DOS, BIOS. I keep getting... I'll mix up the DOS and the BIOS video thing consistently. You know, I'll call it BIOS, I'll call it DOS. I'm probably wrong both ways, never mind. But yeah, we're setting AL to 13, because that's the video mode we want. We call BIOS interrupt 10, and pass that in, and then it goes into VGA mode. We probably should go back to text mode when we're finished. And then we'll just do something so that the program doesn't immediately run. Like if I save it and then compile it and then run it, there, it ran, but it quits immediately because that's what the program does. So what we do is we do that, it'll then wait. There, we're in 256 colour mode. Isn't that nice? What I've not worked out is how to indent a block of code. So if you know how to do that, please tell me, because I know there's something like Control B. Ooh, smiley face. Alt B I. No. See, I've forgotten it. I don't know how to do this. I'll go look in the manual. But if you know how to do that, please tell me. Also, why is that tab stop all the way over there? Something I don't quite like about this editor is that it does that thing that Amstrad's do where you can just like piss off down the end of here somewhere and start typing. I'm not putting spaces in. It just like, you know, you can move the cursor wherever you like and just start typing. It's really weird. But anyway, we're now in mode 13. Let's draw something on the screen. Let's draw a pixel. It's a palette-based system, so I'm going to use colour number 48 because I just picked that out of my head. And we'll put it at position 100. 200. No, that'd be down the bottom of the screen. 100, 100. And let's run it. Oops, that's not the run button. Control F9, need to remember that. There we are, look, got a green pixel in the middle of the screen-ish. That'll do. So we're drawing pixels on the screen. Isn't that wonderful? Bear with me, I just forgot how rough these old editors are. Remembering 25-year-old C programming is one thing, dredging up equally old muscle memory is something entirely different. We'll get there eventually. I need some more help, Internet. I'm tidying up the code to make it a bit more usable, and I've managed to get it in a nice little set of functions like this. The tabbing is annoying me. So I'm at the start of the line here, I press tab, I go there. I press tab, I go all the way over there. Why there? Why not there? Because if I go into options and environment and editor, tab size is 4. I've got auto indent turned on. I don't want to put actual tab characters in my file, I want spaces because I'm part of that group of people. But I don't get it. And there's nothing else I can check. I've even read the manual. But just in case it is, use tab character. Let's do that. It is. But why can't it insert spaces instead? Why has it got to take it all the way over there? Which isn't even a number of tab stops. I guess I'm just going to have to like live with having actual tab characters in here, aren't I? Well, anyway. I'm only going to use it in this editor, so I guess it doesn't really matter. But anyway. Being able to poke video memory is satisfying. There's no batshit insane memory banking hoops to jump through, no weird functions that hide stuff from us, just some memory mapped I/O and a compiler. But we can also speed the code up. I'm going to show you one way. But everything you've ever watched on a PC in DOS has got to talk to the video card in some way. The fastest, most expressive video and pictures that we've ever seen in DOS all come down to being able to plot single pixels on the screen in varying ways. So I feel if I dig around enough on the internet, I'll be able to find the most optimal way of doing this stuff. The stuff I'm about to show you is pretty good, so we'll go with that for now. I've tidied up the code a little bit. I've made some functions to plot pixels in set video mode, and this should draw a bunch of dots all over the screen. Oh, something about this editor that you have to remember to do is it does the same thing as Turbo C. That if you don't save the file, it compiles out of memory. So it's storing the entire file in memory, and then compiling that. So if I quit and don't save, I lose all my code. Or more likely, because I'm not going to quit and not save, that's stupid. If I crash my program whilst running it inside the editor and I have to reboot the machine, I might lose all my code. So we have to remember to press F2 quite a lot. It doesn't like round. Have I done this wrong? Bear with me whilst I make elementary C programming errors. We'll be back when I've remembered how to write C code. I knew it was rand, I just didn't include stdlib. Okay. Can we Google? I need to get my K&R book out, don't I, and sit with that open too. However, did we cope without the internet? Oh yeah, we read books and remembered stuff in our brains and actually understood what we were doing. We didn't just copy and paste from a screen to another screen. That's kind of why I do this, because otherwise I forget what I'm doing and it just becomes copying. Let's compile and run, and there's errors. Oh, this is painful to watch, isn't it? Look at that, I'm missing a semicolon. Save, run. Hey, there we go, that's what I was after. Look at that, lots of dots. Oh. So you know I was saying about, if I crash my computer, I might lose all my code. Well, this is stuck in an endless loop. It's very pretty, but I've got no way of quitting it. You can't just Control-C out of this stuff. My machine is now frozen, running this piece of code in an endless loop. There is no way to quit it. This isn't Windows, so I can't Alt-Tab out of it. It's DOS. This is now fully controlling my computer, this little program that draws dots. The only way out of it is to actually reboot the machine. Now, on an emulated machine that boots quite fast, this is fine, it's not a big deal. I remember doing this in DOS on my real PC, and it could take 30 seconds to get through the BIOS. So obviously I meant while count minus minus. Oh, I didn't save it then. Ooh. There we are, we've drawn some dots on the screen. That actually looks quite nice, quite like that. Right, we've got some pixel plotting routines. However, if we read this a bit further on, we've got plotting a pixel quickly. Because, like this wants to tell me, this is using the BIOS to do all the pixel plotting. We can just go talk to the card directly. We can just map the memory of the card into a pointer, and then go poke at the pointer. But then if we keep reading a bit further down, we can do the maths even quicker by doing that instead. So let's fix our little program to do this. That's some cryptic DOS programming for you. Had this funny concept of far pointers, and then memory locations that are massive, because it's a whole machine. We can go play around with it, poke at things directly. and wherever the VGA card is mapped is quite high up in memory, out the way. So that's how we talk to it. Then our plot pixel function doesn't need to look like this anymore, and in fact, it doesn't even need to be a function. If we can avoid making function calls, we can make faster programs. It can be a macro. There, we'll do that instead. So we'll get rid of plot pixel completely. And then we'll do it using the new fancy one. Place your bets whether I've written sufficient code that will compile. No. These assign a value that is never used. I don't care. I really don't care. There we go. That worked. That tiny little C macro I wrote is the basis for everything that appears on the screen. Like literally everything. What we do from here on is just variations on that piece of code. If I want to draw shapes, I need to program the algorithm to do it. Well, what's better than single points? Let's do some lines. Let's draw lines on the screen. So now that we can plot some pixels, let's draw some lines. Which we have to do by ourselves. There is no line function, we just have access to video memory, which is a big line of pixels, and we have to put them on the screen in a way that looks like a line. There are some standard ways to do this, which are explained elsewhere on the internet. I'm not going to teach you how to do it, mostly because I don't actually understand it myself. But that doesn't matter, because there's code on this page that we can just borrow. Once we get past all the scary maths, here we go. Mr. Breezenham's line drawing algorithm. Let's make this. Let's make a load of lines that just jump around the screen. Now I'm going to slightly cheat by opening up the source code for this, because they've got it inside. I can't just copy and paste this, there is no way of doing that. 86 box doesn't have paste, you can't just go to anything up here and paste, it doesn't work like that. So we will type bits out by ourselves. But first let's just look what the code is. Look, there's that plot pixel. So this is the routine that we want. All of that, which doesn't look too difficult to type out. However, if we just go back to this, there is a little sort of optimization we can make as well. So this bit here where it talks about drawing rectangles, there's no point using this code to draw horizontal and vertical lines, because it's doing all this maths to work out how many pixels before it starts going up or down to the next one. And if it's just a straight horizontal or vertical line like a box, it can just do that regularly. All it needs to do is work out which way to draw the line, and then just use a for loop to turn on the pixels that we need to do. And in fact, because it's drawn a rectangle, there's a way of drawing both the top and the bottom and the left and the right at the same time. So we'll steal some of this and we'll kind of mix it all together. We'll do a bit of Breezenham line drawing algorithms, but a way to check if we're drawing straight lines, and then we'll steal some of this code as well. I think I'll start by just making it draw lines, and then we'll see if we can improve it. I know it wound a few of you up in my last videos where I was doing for loops the modern way, but here we go. I have to do it the correct way, as it were, now, so let's just carry on. Can we get through this typing without making any mistakes? Place your bets down below in the comments. Nope, made one already. Why are we multiplying those by 2? What are we doing? I don't like the fact that that's there. Let me go there. Right, that should do. Let's see if this works. First we'll save it. Just compile it. Okay, doesn't know what SGN is. What are we including to do that? I'm guessing mem.h? No. Oh. Well, let's read the source code properly. It's right on the screen there. Also, put your macros in capital letters, people. That's the unofficial rule. That way you know it's a macro. There, look at that mess. That's wonderful. If x is less than 0, return -1. Otherwise, return... If x is greater than 0, return 1. Otherwise, return 0. So if x is less than 0, it returns -1. If x is bigger than 0, it returns 1. Otherwise, it returns 0. Those things in C make writing code easy. Oops. Let's actually change our code so it works. SGN. SGN. Right, it still does that. It doesn't crash. I guess that means it works. Have they got some code in here that just draws random lines on the screen, so I don't have to think too hard. So I want this. It's just making random X and Y locations all over the screen. There we are. That'll do. Let's have this bit. I'm going to make the screen width and screen height. Didn't bother because the screen can't change size, but it's easier to type in. So the screen is 320 wide. It's 240 high. Right, if this works, we should end up with a lot of lines all over the screen. Nope, we forget to put semicolon at the end of it. Hey, that works. Look at that. Pretty lines everywhere. So if we think about this code, it's doing a lot of maths to work out how best to draw a line. But if we're drawing straight lines, we don't need to bother doing any of that. We can just do this for loop type thing. So we need to work out if we're drawing a straight line. So I guess it means if dx is 0, that means the x positions are the same, so it's a line that's going up and down the screen. And if dy is 0, that means it's a line that's going across the screen. Which I think then means we can cut out all of this code completely and replace it with some of this instead. So I guess we need an if. Now I looked in the manual, and it does actually tell me how to indent a block, so I'll just go find that again. Indent block. Control K, I. Okay, see what that does. Control K, I. 2, 3, 4. Why does it not indent it by the amount that the tab stops are set to? Please tell me, if you know. Is there a way of making it just do that properly? Or had that not yet been invented? Right, so, drawing a vertical line. We need to know which way around to do this. Right, it feels like this might work. I've got code for drawing vertical lines and horizontal lines. And then the slopey lines. I'm curious whether it actually does this code and whether it does this stuff. But then, let's see, I'm drawing a line diagonally down the screen. And then a line going straight down the screen. So at least we should get 2 lines. Now we do, but what's going on? Why is that? It's like it's gone off the bottom and come down there, and it's gone down there, it's popped down here. And it's spaced it by that much. You know, if it was going off the bottom, I would have expected it to come on like the next row of pixels, not that far apart. Okay, well, let's work out what's going on. I told you I'd do that wrong. It's 320 by 200. Reviews with the screen size of the computer now. Yeah, 320 by 200. It's because I think of 640 by 480 divided by 2, but it isn't. Okay, now that's better. Okay, it goes to the corners and it goes straight down. Perfect. Now let's just comment out some code to check it's actually using the right pieces of code. Right, we have a straight line. The diagonal line isn't there, so it was using that correctly. Let's draw a straight line across the screen. I'm seeing if this goes over by 1 pixel on the side of this screen. I think it will. No, it just doesn't draw it at all. That's very interesting. Maybe colour 20 is black. Colour 3 can't be black. No, it's just not drawing it at all. Oh, it is. It's at the very, very top. Which doesn't make any sense. It should be 100 pixels down. It should be in the middle of the screen. Let's just look and see if I did this correctly. So if x1 is bigger than x2, we're starting at x2, we're ending at x1. Otherwise, we start at x1 and end at x2. Yeah, it shouldn't be dy, because that's 0. That should be y1. Could be y2, doesn't matter. Look at that. We have lines. Also, no, look at this. This one here is correct. This one is 1 pixel off, so actually we need to do 320. Not -1. That's better. Look at that. It actually looks like some sort of crosshairs thing in space. And if I turn this back on, I shouldn't get any of these appearing because I've disabled all that code. Apart from the straight ones, yes. Right, let's turn all the slopey ones back on. Well, that was only mildly time consuming, wasn't it, really? If you're still with me, let me know in the comments. Give me ideas for future videos that I could try and find out how to do. I think I want to recreate old school demo effects now that I've played with this for a while, because they're good programming challenges. I might even try and get some assembly language in it at some point. Also, if you are still awake, hit the subscribe button. I've randomly decided I want to get to 50,000 subscribers and learn how to speak properly, because I think it'd be a laugh. So having drawn lines, I think it's time to draw some patterns, because I've got an idea. So we're trying to draw a little pattern. Let me just try and find the sort of pattern that I mean. Sort of these kind of things. Ooh, don't know how you do that. Remember these because my grandparents used to have a picture made from this stuff stuck on their wall next to their really nice 1960s looking wallpaper. And it actually had physical pins in the board with string between them. So it's possible that my mum made it or something and they stuck it on the wall. It feels like a school project. Is that BBC Micro Owl? Kind of. String art. Yeah, there we go. This is the thing. This is exactly what I mean. So you can see how we build this up. We have X and Y coordinates and we just go from... They always go to the furthest one away. So that one is going to here. That one is going to the next one and so on. And it makes this sort of curve. Right, that's what we're trying to make. So I think this should work. We're going across the screen for the entire width. And we're drawing a line from wherever that point is at the top, which is 0, to the other corner, minus how far we've gone. So this is going to create a sort of, you'll see it in a minute, I know what this looks like in my head, to the height of the screen. Oh, we need to put colour. I don't know, colour 4. Yeah, that looks exactly like what I thought it'd do. Need to space it out a bit. So we'll do x plus equals 2 to leave a gap, and screen width divided by 2. Looking better, it's still too filled in the middle. Pixels are still too big. Do it by 4. That's more like it. But I need it to do it to the middle of the screen, not the far right corner. So screen width divided by 2. Ooh, that's kind of... no. But interesting. I'll just press Ctrl F5 then. Meant to press Ctrl F9. And I've realised that I'm going from the top to the bottom and I should be going from the sides to the bottom. So let's get rid of all this dividing by 2 business. And we'll come back when we've turned our brain on a little bit more. You know, for such a simple pattern, that was weirdly confusing. I cut out a lot of painful debugging. I return you to the action, right where I'm full of confidence, driven by a nice hot cup of tea. This is going to work. I think this will work. I'm trying to imagine it in my head. That is clearly a very, very slow piece of code, because I can see it happening. And it was drawing it from the middle of the screen, which it should not be doing. Probably spotted that, I didn't. You don't put Y as X. That's not a thing. That's sort of right, but also not. And I realise this needs to be square, but the screen is not square. And that's a really nasty orange colour. Try colour 7. Sometimes that's white, I think, on computers. So we're just going to make a thing up here that says how big this is going to be. So it'll be 200 pixels. Let's make it draw it in different coloured stripes, just to see what it's doing. Ugh, that's not how we do a hash define, is it? Oh my god, my brain. I know it's late, but still. How long have we been coding? Ooh, that's not what I expected. That was quite cool though. I don't know why it was doing that at all, but I liked it. I think I've just worked it out, because we've got 2 for loops. Let's run it again. I like the way the colours sort of slide up the thing. Ah. Didn't mean it to do that. I really don't need to do this for loop. All I need to do is go y1++. Nope. But again, kind of cool. But no. I'll come back in a minute. If you're still here and haven't quit thinking, who's this idiot that can't write code that works, I'll let you into a little secret. We lie to you in YouTube videos. We possess video editing software that lets us cut out mistakes, and we can redo entire sections of video to get it just perfect. It's quite difficult showing you mistakes in full view of the public, so it's easy to just snip them out as if it never happened and look perfect. But we don't do that here, as you may have noticed. 90% of programming is actually just banging your head on your desk, questioning your life choices, and then 10% typing. Sometimes it's only 89% head banging, and that leaves you 1% left over, which is the satisfaction when the thing works. But that 1% satisfaction is the point. It makes up for all the hours spent staring at the screen wondering why. Why is this broken? Why don't I understand it? Why did I choose to do this in the first place? Why don't I go and become a nomadic goat herder where the only debugging involves picking crawling insects out my food? Why have I chosen this mad pastime? So, I return you to more blind fumbling in the dark because I accidentally discover something cool. You do this if you play around a bit, you find fun things. You can't plan this stuff. Okay, yeah, sometimes you have to pause and think for 3 seconds. Like, how's about we set y1 to a value? Because we didn't. That's what we're after. That's perfect. That's exactly what I meant. Yeah. Subscribe for more elementary C programming mistakes. We've had everything from not including the right libraries, to missing semicolons, to not initializing variables. Come join me, see what other basic mistakes I can make. Right, so let's get on with making this look a bit nicer. x1 plus equals 2, y1 plus equals 2. Should spread it out a bit. Getting there, it's doing what I was expecting. Yeah, that looks like it. Right, let's just pick one colour. What's in the palette at that position? Nasty. But that's what I mean. That was weird. Okay, that was just the emulator going funny. Let's make it go the other way. Across the other corner. So we have 2 with the funny little diamond shape at the middle. I think it's something like that. Not quite sure. Let's have a go. Yes, yes it was. That's what I'm after. So we sort of made part of one of these. I quite like that. Not sure how to make it. Or these things. In fact, the other thing is this stuff. Let's kind of go and turn our brain off for a minute. That's it, those things. No, I don't want to use matplotlib. No. No. No, stop using Python. Oh, show me Pygame. Oh no, it's showing it with Pygame. What's this GCD thing? Oh, okay. I see. Right, I'm going to go away and have a think. This wasn't really intended, but I've gone down a rabbit hole. Not content with churning out meaningless slop that doesn't work, I'm now going to try and force this code to work. Pretend this is an intentional demonstration of why you can't use ChatGPT to learn new things. When it's wrong, you don't realise until you've wasted hours on it. Do as I say, not as I do. I don't know if this ChatGPT code even works. It's got sine and cosine in it, so let's go killer 486 trying to make it calculate that. Okay, I've written some code. I do not know if it's going to work. I just literally copied it from the ChatGPT stuff, which I don't know it's going to work either. I've done this kind of thing before. The code looks vaguely sort of like the thing I saw before. I remember capital R's and small r's and sine and cosine. Yeah. Let's see if this works. Let's see if it even compiles. Right, errors. Right, so we need to encode a prototype, because of course yes we do, and we need to set num points. Yeah, didn't really think it'd do anything. Unless colour 4 is black. No. Oh, there's a piece of code missing. Forgot to do that bit. No, still did nothing. I don't think ChatGPT is going to be stealing our jobs anytime soon, do you? I mean, it's one thing getting it to write web page articles, but the thing about code is that, well, it actually has to work. And this AI generated code doesn't work. So you can faff around in ChatGPT all you like and dump code into an editor. If it doesn't actually work, you've still got to fix it. So while it might remove the need to type out pages of boilerplate code that's quite tedious, you're still going to need to know what's happening in order to fill in all the gaps it can't fill in. Now I know some of you get a little bit grumpy when I use ChatGPT, because it's like cheating and not thinking. But I really don't care. But I'm quite impressed that I asked it to convert that to ANSI, and it figured out that it can't do that using Pygame, so it's using SDL. Because, you know, that actually makes sense. So let's compare. So okay, I've used ints, I should use double. I think that is probably the problem. I set the colour, so I think it's the fact I had the wrong data types. Okay, this is not complete bin fire just yet. Sorry, little Pentium. Sorry, it's not even a Pentium, is it? Sorry, little 486DX, but we're going to play some doubles, precision, floating point numbers. I can't be, because you can't use a double in a for loop. DOU, BLE. We've got X and Y, and we have to convert them back into integers, which is really going to destroy performance. Save it, because it might crash. Ooh. Well, it's not complete rubbish. It actually sort of looks like the thing that it probably should look like. Let's change some numbers. Like 140 and 60 are probably fine for that, but the number of points needs to be bigger. Put 1,000. No, that didn't help. I feel like we possibly went over some sort of size of an integer thing then, calculating numbers. Yeah, it needs to be smaller. Let's set that to 50. Right, well that's got a different shape. I like it. It's got bits missing and there's weird crap down the side of the screen. Looks like an atom. Or at least it looks like an atom when I was at school, before they decided atoms didn't look like that. Oh shit, I've crashed it. Oh no, there we go. No, I don't know. The code that I'm looking at looks the same, so it's either broken or I don't know what. I feel these pixels should be in here and these pixels should be in here. Something's got a bit wonky. Right, I've found some maths written in C#, which is C with knobs on. Kinda looks the same. Okay, enough of that nonsense. Let's do the morally acceptable old-fashioned way of doing this. We're going to copy other people's code. It's AI code generation with even less intelligence, but at least it's not artificial. All natural code stealing. We'll call it that. Right, I've been clicking around the internet for a little bit and I've found this place that's got a bunch of algorithms in it. I might have to go and play with this. This looks quite interesting. No idea what's in here, but there's one called spirograph.c. So let's do a bit of copy pasta and see if this works. Remember, this came from another human being. I'm allowed to copy this because it's not AI, remember? AI bad, human good. So I was just compiling the code to see if it worked, and it popped up 2 error messages, well, warnings from the compiler, telling me that end and start are not assigned, are assigned a variable and never used. What it's talking about is this bit here, where I work out where the start and end of the line is, and then I don't do anything with it. So let's get rid of that, and let's get rid of that. Because we don't need it, yeah. So even if this spirograph thing never works, at least I made this line drawing code a little bit simpler. I keep pressing Control-C instead of Alt-C to compile. Let's run it. It shouldn't crash. It doesn't crash. That's good. Now we need to draw these points that we've just calculated, apparently. Let's work out how to do that. They're just points. Let's just plot them on the screen. We don't have a variable called I, do we? Let's have another one. For I equals 0, I less than n, I plus plus, plot, pixel, x, I, y, whoops, y, I in color 6. Illegal use of floating point. Yeah, obviously it is. Because that's not what we do, is it? We turn it into an int. And we've got a red dot in the corner of the screen. That's not really what I was expecting. Let's try something different. Doubles are an F. Let's actually see what it's storing. Oh, okay, they're all numbers between 0 and 1. So, yes, it's an offset from the middle of the screen. Okay, we need to work out to multiply that and shift it by something. So let's times it by 10 and add screen width over 2, screen height over 2. Right, they now look like numbers that probably will fit on the screen. So let's stop printing them. Let's take this bit. Huh. Don't know what the f that is, but that's kind of fun. Maybe we need to times it by a bigger number. 20? Ah, 50. Oh, that's quite pretty. 100? So I don't want to make it too tall that it goes off the top of the screen. Yeah, see, that's probably about the most we want to put there. Let's play with some numbers. I know what 0.3 means, let's make it 0.6. Okay, let's make the rot be 30. No, don't look any different. What happens if it's a number bigger than 1? It explodes and goes mad. Ah, we're getting somewhere. Look, there's a pattern. Needs more dots. I guess there's a limit to the resolution of the calculations that we're doing. Probably should be drawing lines between them, which means we can get away with less dots. Why does it not move the cursor to the end when I paste? That's mad. We'll have the same nasty colour 6. It's going to be I plus 1 plus 1, but we're going to mod that by n so it goes back to the beginning. Right, it needs scaling so it doesn't go quite as far. That's crazy. I don't know why it's gone weird and drawn off the edge of the screen. Let's just do I plus 1. No, whatever. I think I like the previous one, without drawing lines on it. That rot thing doesn't seem to make any difference. Oh, maybe it does. Right, that's how many times round it goes. So I guess it's drawn over itself multiple times. That is a maximum it needs to go. Ah, pointy one. I think the last thing I'll do, because I think this has gone on long enough, is make it have pretty colours. So we'll just make that be an N. Nope, I'll make that be an I. Some definite nicer, brighter colours than others, isn't there? There, pretty pattern. Pretty pattern in some code that does things and is probably really unoptimized, but I don't care. It works, it looks pretty. I've learnt a bunch of stuff. I've drawn some pixels on the screen. Went from literal nothing to some pretty pixels on the screen. There we go. I think that'll do. Thanks for watching all the way to the end. You're one of the 10% that makes it this far. It's really appreciated. That was, despite all the sarcasm and piss taking and stuff, actually pretty fun to do. I mean, the sarcasm was fun as well, that's just me. Hello. I like starting from a blank file and creating something new. It's quite satisfying. But where do I go next though? I think I need to poke around the internet and find some nice little routines for graphics effects. Having access to the display as a giant array gives me lots of options. Scrolling text, parallax scrolling backgrounds, those fancy zooming tunnel things, fractals, whatever. I think this bit might mutate into me writing demo effects amongst other low-level programming challenges. So, if this is your kind of thing, consider subscribing. Also, if you like this content, come visit my new and improved website. That's where I have a blog and I write things in more detail that don't fit in a video, because while you'll watch me talk about code, going through it painfully line by line is probably a little bit too much. And until then, I'll see you next time. Do as I say, not as I do. I say that far too often at work as well. Pause! Pause, you fucking thing. This thing is doing my head in. I need a better one. It's like the Bluetooth doesn't work half the time.